Here's an example that reminds you to be careful when you're computing the potential of a vector field through integrating each component with respect to dx, dy, dz, depending on the component. So this one is asking find the potential of the vector field. And the vector field is f of x and y equal to y over x plus y in a parentheses to power 2 and then negative x over x plus y in parentheses to power 2. On the domain D, where D is x plus y bigger than 1. Immediately, domain doesn't include any holes. It's simply connected. So let's try to see if f is conservative. That's the next step. So let's compute curl of f, and curl of f is the partial with respect to x of the y components minus partial respect to y of the x component times k. Computing that partial, you get negative parentheses x plus y parentheses close to power 2 plus 2x squared over x plus y in parentheses to power 4. Then minus x plus y in parentheses to power 2 minus 2y squared over x plus y in parentheses to power 4, and the entire things times k. Clean this up a little bit, expand x plus y to power 2, and then you realize that the curl is actually the 0 vector. And domain, again, we said there's no holes and is connected in R2, so it is simply connected. Now, what are the antiderivatives? Now, let's try to take the integral of y dx over x plus y in parentheses to power 2, and this integral of the second component with respect to dy. The first component and the antiderivative gives me negative y over x plus y plus c1 of y, because the antiderivative was with respect to x, and the other one gives me x over x plus y plus c2 of x. Here I can imagine if I want to include this in the antiderivative, it has to be a constant for the other format of the potential. See, both of these are one or another format of the potential. If this is not appearing in here, it has to be a constant in here, and it's not, because it includes the y in here. And the other way around, this one is not there, but it's not a constant over there because it includes x, basically. So something is off, because we figured out the curl is working, everything is working. Basically, the constant in each integration is sort of mixed in with the function of that variable. So how do we do this? Very quickly you can note that x over x plus y is actually 1 plus negative y over x plus y. And so basically the two functions that we have, even though one is not the constant of the other integration, basically they contain some constant that change the. So now that I know that x over x plus y is equal to 1 plus negative y over x plus y, I can replace that by what it is. So now through the replacing, I can see that both integrations resulted into minus y over x plus y and a constant. And I called this one 1 as c3 of x. Anyway, it's a constant in terms of x. So I can choose the function now that it's actually appearing in all of them, and not to worry about it being constant in the other ones. And so that becomes my potential minus y over x plus y, plus an actual constant c is the potential in this case. But as you saw, that this process of checking whether or not some result of integration is actually constant for the other integration was essential in this problem.